My name is Anthony Nathaniel, and today I'll be taking you a special topic in mathematics known as logarithm. Now, you've probably heard of what's called standard forms, right? Standard forms are forms where you express numbers, such as imagine we have a number like 4,322. Now, if I wanted to express this number in standard form, what I'll do is that I'll count to the left. So I'll count till I get to the whole number. That's the first whole number I can see. Now I'll count to the left. I'll count 1, 2, 3. Now I've gotten before the first whole number, which is 4. So I will stop there. You will stop at the first whole number you can see. Then you write it. You write the number itself, 4. Then you put your point, 4.33322. Then you now put times. Then the amount of times you turn before you go to your whole number, you count it. So I turned 1, 2, 3. That means my answer will be times 10 raised to the power of 3. So that is how you express in standard forms. Let me give another example. Imagine we have a number 0.0024. Now with this number 0.0024, if I wanted to convert it to standard form, what I will do is that this time around, if I'm working with decimals, I count instead of to the left, I count to the right. So with decimals, I count to the right this way. So now I will now begin to count this way. So but now you will start your counting from your decimal point, which means I will start from this decimal point. So I will count till I get to after the first whole number I can see. So now I will count to I've counted 1. 0 is not what I'm looking for. I'm looking for numbers between 1 and above. So I won't stop at 0. 2. I've gotten after another 0, which is not what I'm looking for. So now I've gotten to 3. When I counted 3 times, I've gotten to 2. So now I'll stop at this after when I get after these 2. So now I will now write my number, which is 2, including decimal point. 2.4 times 10 to the power of. Now how many times did I count? I counted 1, 2, 3, right? So that's 10 to the power of what? 3. That's 3. That is how you express in standard forms. Now we are going to expound on that knowledge, and we are going to establish the basics of logarithm. Now a logarithm is basically a special number that expresses the power to which another number is raised to get that number. Now a logarithm of a number is simply defined as the power of that number, or the power of the base. A base is like the standing ground of the number. A base is like where you take the logarithm from. So now if I have a number a, the logarithm of a number a to the base b is basically the power which you have to raise that base b to in order to get the number a. So to repeat myself again, the logarithm of a number a to the base of b is simply the power you have to raise that base b to get the number a. So now we are going to deal with a specific logarithm. Now let's give an example. Example of logarithm is, imagine we have a number 2.003. Now logarithm of numbers, they can be whole numbers. Logarithm can be 10, logarithm can be 15, logarithm can be 20, logarithm can be 100. But in your mathematics course, you won't get to all those bigger numbers. You will mostly be dealing with numbers between 1 and 10 and 20, and then decimals. Now in this number, this is called a logarithm, and then this special logarithm, we call this 2. This whole number is called the characteristics. And now a whole number is a number before your decimal point. It's called your characteristics. Then your number after your decimal point is called your mantissa. Now your number before your whole number is called your characteristic. Number after your decimal point is called your mantissa. Now we are going to be dealing with multiplication and division of numbers. Now this is a special application of logarithm where you can use your logarithm knowledge to multiply and divide numbers. Now in another video of this channel, I will be teaching you how to make use of your logarithm table, because when you want to calculate logarithm, you have to make use of your logarithm table. But for today, I will just give you the direct values from the logarithm table. But you can refer to another video of this channel if you want to know how to read and logarithm and anti-logarithm for your logarithm table. So now let me give an example. Example 1, let's calculate 76.7. Example 1, let's calculate 76.7 times 308.2 divided by 8.04. Now if you are me, you will just sit down with your calculator and just type 76.7 times this and this. But that would be an easy way, right? But no, in some examinations like your WAEC, you might be asked to use only your logarithm table. So now let's work the way it should be done with logarithm table. Now solutions. Now when you want to tabulate your solutions, you write it, you make tables. One of the columns will be for number, and then the other column will be for your calculation, and the other will be for the logarithm. So now let's make one column of number. This is number. Then another column for the logarithm. Now I've made my table here. Now let me see 76.7. Now before you calculate the logarithm of a number, you have to express it in standard form. Now when you express in standard form, that's your number before your whole number is called your characteristics. Now if I were to express 76.7 in standard form, I will move to the left, and I'll move to the before the first whole number I can see, which is 7. So I'll move one place to before 7. Now my in standard form I have 77.67 times 10 raised to the power 1. That is how I find the standard form. Now I will that power I raised 10 to, which I said 7 times 7.67 times 10 raised to the power 1, right? Now that 1 will be my characteristic. So now I'll write its characteristic of 1. Then your decimal part, the decimal part of your standard form, you look for it from your logarithm table. Now that is 0.67. Now as I mentioned earlier, another video of this channel will teach you how to look for logarithm values from your logarithm table. But now 0.67 is 8848. So that's 1.8848. Now using the same method, let's look for the second number. 308.2. 308.2. Now the logarithm of 308.2 is 2.4889. 2.4889. Now whenever you are multiplying numbers, you add their logarithms. So note, when you are multiplying numbers, you add their logarithm. Then when you are dividing numbers, you subtract their logarithm. You subtract the numerator from you subtract the denominator from the numerator. Now because we are multiplying 76.7 by 308.2, we are going to add their logarithm. So when we add them together, 9 plus 8, that's 17. Write your 7, carry your 1. Then 8 plus 4, that's 12. Right? Plus 1, that's 13. 13. Write 3, carry 1. 8 plus 8, 16. 16 plus 1, 17. Write 7, carry 1. 8 plus 4, 12. 12 plus 1, 13. Write your 3, carry 1. Then you put your decimal point, that's 4 in total. So your numerator becomes 4.3737. That is the logarithm of your whole numerator. Now we are not doing it. It said divided by 8.04. Let's convert 8.04 to logarithm. So 8.04, that becomes 0.9053. 0.9053. Now because we are dividing the denominator, by the numerator, we are going to subtract their logarithms. So we have 7 minus 3 is 4. 3 minus 5, which is not possible. Let's borrow 1 from here. That's 6. That's 13 minus 5. That is 8. 6 minus 0. That's 6. Then we borrow 1 from this whole number. That remains 3. That's carry the 1 here. 13 minus 9. That's 4. Put your decimal point. Then 3. So we have 3.4684 as our answer. So that is the answer of this question. Now before we are done, we have to convert back to logarithm. So when you convert back to our number, you make it of anti-logarithm, and the anti-log of 3.4684 is 2,940. 2,940. That's 3 significant figures. So now let's move on to the next part. Now in the next part, we've been doing this one, right? Let's move on to the powers of numbers. Now I'll give another example and I will calculate the logarithm. So now this second example, we are looking for 3.554 raised to the power 4. 3.554 raised to the power 4. Let's call that number 2. So they said find 3.554 raised to the power 4. Now for this one too, we are going to set up a logarithm table. Let's set up a logarithm table. Let's number the column for number and then the column for logarithm. So now the number is 3.554, right? Now what's the logarithm of 3.554? So anytime you have a number between 0 and 1, their logarithm always lies between 1 and 10. So you can check your mathematics books for all these rules. There are several rules of logarithm. Maybe if God willing I have chance, I will also make another video on the rules of logarithm and for further things you need to know. Then but the logarithm of 3.554 is 0.5502. 0.5502. Now, anytime you are raising a number to a power, you multiply the logarithm by that power. Now, we are raising 3.554 to power 4, so we are multiplying the logarithm by 4. That's times 4. So we have 4 times 2, that's 8. 4 times 0, that's 0. 5 times 4, 20. Write your 0, carry your 2. 5 times 4 again, 20. 20 plus 2, 22. Write 2, carry 2. 4 times 0 is 0 plus 2, that's 2. So our answer is 2.2008. Then when you are done calculating, you now convert it back to your number and you make use of your what? Anti-logarithm table. So for my logarithm table, that will give us 158.8. 158.8. If you have your calculator now, you can even verify this. You can check it out and you see that if you calculate the 3.554 raised to first power of 4, you will get 158.8. So it's always correct. It's never wrong. Now let's move on to calculations of logarithms less than 1. So I know I said earlier that when you have a number between 1 and 10, their logarithm is between 0 and 1, right? Now what if we have a logarithm between 0 and negative number or minus 1? So what do? Let's check that out. So now let's evaluate so now example 3, let's find 0.7685 0.7685 times 0.03415 0.03415. Now in this question, the first thing you are going to do is you are going to convert your question to standard form. So now let's convert to standard form. This is decimal, so we are counting to the right. So let's count one place till we get to the first non-zero number and non-negative number or non-zero number. So now we've gotten to, if we count 1, we get to 7. So we'll stop at 7 because 7 is a positive number. So now let's say the logarithm, the standard form will be 7.685. Then we counted once, so that's 10 raised to the power 1. That's times 10 raised to the power 1. But actually, when you are counting to the right, is a negative. So our power is 10 raised to the power minus 1. So and even in this example I gave earlier, this is 2.4 times 10 raised to the power minus 3. When you count to the right, it's minus. Now this second number is 0.03415. Let's count. So 1, we've not gotten to a positive number. Then 2, yes, we've gotten to a positive number. 3, that's 3.415 times 10 raised to the power. We counted 2 times to the right, so we are going to have our power as minus 2. So after that, you now set up your logarithm table. Number, column for number, column for logarithm. Now we will now write it down. This one, that power will become the matrixer. Sorry, will become the characteristics. Because I said the whole number is the characteristics and then the decimal number is the matrixer. So our characteristics become minus 1 for 0.7685. So our characteristics is minus 1. So but instead of writing the minus 1, you put the minus 1 on top. That's, you put the minus 1 on top, then you now put the 1. So that's minus on top, then put the 1. That's how you write it when you are calculating logarithm with your rough sheet. That's, then now put your point. So the next part is to look for the matrixer. So when you use your logarithm table, you get 8857. 8857. Then for the second number again, we have, which is 0.03415. We have minus 2.5334. Minus 2.5334. Now this is where I really want to teach you. And now listen attentively. Now when you have something like this and you are trying to add them, because they are multiplying the number, so we are going to add their logarithms. So now you now say 7 plus 4, which is 11. Write a 1, carry 1. 5 plus 8, 3. 5 plus 7. Sorry, 5 plus 3, 8. Add 1, that is 9. 9. 8 plus 3, 11. Write 1, carry 1. 8 plus 5, that's 13. 13 plus 1, 14. Write 4, then carry 1. Then this minus 2 and minus 1, you add them together. Minus 1 minus 2 is minus 3. Then you add the 1 that you borrowed. That is minus 3 plus 1, that's minus 2. So your final answer will be minus 2. So you get it. So that is very important for you to know. So now, after doing this, we are going to convert back to logarithm. Now to our real number, sorry, and when you convert back to our real number, our answer will be 0.02625. 0.02625. That is the calculation of that. Then now let's move on to something else. Let's move on to had these numbers were dividing, what would you do? We will subtract their logarithm, because when you are dividing numbers you subtract their logarithm. When you are multiplying numbers you add their logarithm. So I want you to note that. Then lastly, we'll move on to one aspect, the last aspect of this video, which will be multiplication of and division of negative logarithms. So now if we have logarithm of 2 minus 2.7 times 4, when we have logarithm, if it's a logarithm minus 2.7 times 4, so how would you do it? You will not just say minus 2.7 times 4, that's minus 2, you now multiply normally. No, you don't multiply normally here. What you do is you separate your logarithm. Minus 2.7 times 4, that is minus 2 plus 0.7. So let's write as minus 2 plus 0.7. So we include this in a bracket, then we'll now multiply by 4. So 4 times the first term, minus 2 plus 0.7, sorry. So 4 times the first term, we are going to open the bracket. 4 times minus 2, that's minus 8. We'll put the minus on top, minus 8. Then 4 times 0.7, that's plus 2.8. Then we'll now simplify it like this. Minus 2, minus on top. Remember that the minus on top. Minus 2 plus 2.8. So this 2 is a plus, right? Then minus 8 plus 2, that's minus 6. That's minus 6. We'll now put the point. So we'll now put the decimal part is 8. So note that in logarithm you always separate the calculation of the decimal part from the calculation of the non-decimal part. So now the last exercise for this one is, let's look for minus 6.9 divided by 3. Or let's say, yes, let's look for minus 4.7 divided by 3. Minus 4.7 divided by 3. Now we still use the same method, but this time around we know that minus 4 divided by 3 will not give us a whole number. So we are going to tweak the logarithm to get something that will give us a number. If we tweak this one to give us, we'll have something like this. You can, if we're looking for minus 4, we can say minus 6 plus 2 will still give us minus 4. So let's say minus 6. Let's put the minus on top. Minus 6 plus, then let's add the 2.7 divided by 3. So if we condense this again, we'll still get our original number. It does not make it wrong. So you are going to convert your characteristic to a number that can be divided by your denominator. So now we have minus 6 plus 2.7. So now we'll now divide by 3. Minus 6 divided by 3, that's minus 2. Then plus 2.7 divided by 3, that's 0.9. So we now have minus 2 plus 0.9, that's minus 2.9. So you are not, note that you don't add the characteristic and matrices. You do the characteristics separate, you do the matrices separate. So that is the end of my video on logarithm. And if you need much more clarification and teaching on this, you can check the description below. My number is there. You can chat me up on WhatsApp or Facebook, and then we can